All right, are you ready for this? We're going deep today, folks, into some seriously cool space stuff. You know how much we all love space, right? Especially new discoveries. Well, buckle up, because today we're diving into the TRAPPIST-1 system. You may have heard of it a few years back. It was huge GE news. We're working with this awesome YouTube video about it, and it announced the discovery of, get this, seven planets orbiting a single star. And get this, they're all remarkably similar to Earth.
It's really amazing how, even though this was all over the news back in 2017, it's still super relevant today, especially with all the advancements in space observation we've made since then.
Totally. So this video, it really breaks down why this is such a big deal.
Yeah.
So maybe we should start with the star itself, TRAPPIST-1.
Right, so TRAPPIST-1, it's what's known as an ultra-cool dwarf star. And it's relatively close to us, only about 39 light years away, which in astronomical terms, that's pretty close. And that makes it a really ideal candidate for study.
Okay, so a whole solar system, right? Our galactic backyard. I like it. So what else does this video tell us about these Earth-like planets?
Well, first of all, they're all rocky planets, potentially similar in size and mass to Earth. But here's the real kicker. 3 of these planets, they're located within the star's habitable zone, also known as the Goldilocks zone.
The Goldilocks zone. I love that. That sweet spot where it's not too hot, not too cold, but just right for liquid water to exist.
Right, exactly. And liquid water, well, that's considered essential for life as we know it. So the fact that 3 of these planets could potentially have liquid water, that's huge.
Right. I mean, it's enough to make you wonder if we might not be alone in the universe. Speaking of which, this video creator, he seems pretty convinced that out of 7 planets, at least one of them has to have some kind of life on it. What do you think?
Well, it's definitely exciting to think about, but it's important to remember that. Just because there might be liquid water doesn't automatically mean there's life. But it does give us a fantastic opportunity to investigate.
It does. And thankfully, we now have some seriously powerful tools like the James Webb Space Telescope, launched back in 2021. Which can actually analyze the atmospheres of these planets. This wasn't possible before, was it?
Not really. Not with this level of detail. The James Webb Telescope uses a technique called transmission spectroscopy. It's pretty cool. When a planet passes in front of its star, some of that starlight, it filters through the planet's atmosphere.
So it's like shining a light through a colored liquid. And the light changes color depending on what that liquid is made of.
Yeah, that's a good analogy. So by analyzing the light that passes through the planet's atmosphere, scientists can identify the presence of specific elements and molecules, like water vapor, methane, and carbon dioxide.
And certain molecules could be signs of life, right? Like oxygen, for example. If there's a lot of oxygen in the atmosphere, doesn't that mean there's something breathing on that planet?
That's the idea. The presence of certain molecules, particularly in specific combinations, can act as what we call biosignatures, indicators of potential biological activity. But interpreting these biosignatures can be really complex.
So even if we find those molecules, it doesn't necessarily mean we've found aliens.
Exactly. We have to consider other factors and rule out any other possible explanations. For example, methane. Well, methane can be produced by geological processes as well as biological ones. So it's really all about carefully analyzing the data and looking for multiple lines of evidence.
Man, this is getting really interesting. I'm already hooked, and we're just getting started. This TRAPPIST-1 system, it seems like it has a lot more to offer than just the possibility of alien neighbors.
Oh, yeah. You're absolutely right. Each of these 7 planets, each one possesses unique characteristics, offering scientists this sort of cosmic laboratory where they can compare and contrast different planetary environments.
Oh, wow. Okay, so could you give us an example of this? How are some of these planets different from each other?
Well, let's take TRAPPIST-1 in, for example. It's considered by many to be the most potentially habitable because of its density, which suggests a rocky composition similar to Earth's, and its potential for having a substantial water ocean.
Whoa. A whole ocean on another planet. What about the other planets? Are they all as promising?
Well, not necessarily. TRAPPIST-1c, that one might have what we call a runaway greenhouse effect, similar to Venus. This means its atmosphere traps heat, leading to crazy high surface temperatures, making it much less hospitable to life as we know it.
So even within this one system, we see this huge diversity of potential planetary conditions.
Precisely. And by studying these variations, scientists can learn a lot about planetary formation, atmospheric evolution, and all the factors that go into influencing a planet's habitability.
Wow, it's mind-blowing to think we can get these glimpses into other worlds, even from such a huge distance. What do you say we delve a little deeper into the individual characteristics of these planets?
Absolutely. Let's start with Trappist 1b, the innermost planet. This one's so close to the star that it completes an orbit in just over one Earth day.
Whoa, that's fast. Okay, let's hear more about Trappist 1b and all the rest of its planetary siblings. I'm ready to learn about all of them.
Yeah, Trappist 1b. It's a fascinating world. It's likely tidally locked to its star, meaning that one side is always facing the star, while the other side, it's always in darkness.
Kind of like our moon, always showing us the same face.
Exactly, and this creates these extreme temperature differences between the two hemispheres, making it, well, pretty unlikely to support life as we know it.
Okay, so maybe not the best place for a vacation home. What
Okay.
about the next one out, Trappist 1c? You mentioned it might be a bit like Venus.
Yeah, Trappist 1c, it's thought to have a really dense carbon dioxide-rich atmosphere, potentially leading to a runaway greenhouse effect, similar to what we see on Venus.
So scorching hot surface temperatures, definitely not a top contender for habitability then.
Not for life as we know it, no. Studying planets like Trappist 1c can help us understand those factors, the factors that contribute to runaway greenhouse effects, and that delicate balance that's needed for a planet to remain habitable.
Right. It's like learning from the extreme examples to better understand what makes our own planet so special. So what about Trappist 1d? Is it any more promising?
Trappist 1d, it's an interesting case. It's right on the edge of the habitable zone, meaning its surface temperature could potentially allow for liquid water. However,
Yeah.
it's also pretty small, perhaps only about 30% the mass of Earth.
So it might be too small to hold on to a substantial atmosphere.
Yeah, that's one of the big questions scientists are trying to answer. Its low mass and weaker gravity could make it vulnerable to atmospheric loss.
Okay. On to Trappist 1, the one you said is considered the most Earth-like. What makes it so special?
Trappist 1, it's located right smack dab in the middle of the habitable zone. It's estimated to be slightly larger and more massive than Earth, with a similar density, suggesting a rocky composition.
So it's got the right location and the right size. What else do we know?
Well, based on current models, scientists believe that it could have a substantial water ocean on its surface. And if it does have an atmosphere, it's possible that it could be similar to Earth's early atmosphere.
Wow, that's incredible. This really does sound like the most likely candidate for life in the system so far.
Yeah, it's definitely a top contender. But we still need more data to confirm if there's an atmosphere and what it's made of.
Well, let's hope the James Webb Telescope gives us some answers soon. So what about the last three planets, Trappist 1F, G, and H? Are they as interesting?
They are. They each offer some unique insights. Trappist 1F and G, they're both in the habitable zone, though they're a bit further out from the star than E. This means they're probably colder, possibly with icy surfaces, or even subsurface oceans.
Like Europa or Enceladus in our own solar system. Those moons with potential oceans hidden beneath their icy shells.
Exactly. And then there's Trappist 1L, the outermost planet. It's so far from the star that it receives very little light and heat.
Sounds like a pretty chilly place. Do we know anything about its composition?
Not much. It's the most difficult to observe. But it's possible that it's a Neptune-like ice giant, composed mostly of ices and gases.
So we've got a potential super Venus, a few maybe Earths, some icy water worlds, and maybe even an ice giant. This TRAPPIST-1 system is packed with variety.
It really is. And remember, this is just one system out of billions in our galaxy.
It really boggles the mind to think about how many other planets are out there and how many of them might be even more Earth-like than these. But let's not get ahead of ourselves. We were talking earlier about how the James Webb Telescope can analyze the atmospheres of these planets. Can you explain a bit more about how that actually works?
Sure. When a planet passes in front of its star, from our perspective here on Earth, some of that starlight passes through the planet's atmosphere. This is what we call a transit.
And that's when the James Webb Telescope does its magic.
Exactly. The telescope's instruments can analyze the light that's passed through the atmosphere, essentially splitting it into its component colors, like a rainbow.
And by looking at those colors, those wavelengths of light, scientists can figure out what's in the atmosphere.
Precisely. Each element and molecule absorbs and reflects light differently, creating a unique spectral fingerprint.
So by studying these fingerprints, scientists can detect the presence of things like water vapor, methane, oxygen, and other potential biosignatures.
Yeah, it's the idea. But it's not always straightforward. Sometimes the signals can be faint or obscured by other factors.
I imagine it takes a lot of careful analysis to tease out those subtle clues, especially when you're dealing with planets that are so far away.
Yeah, you're right. It's definitely challenging, but an incredibly exciting field of research. And the James Webb Telescope, well, it's already made some remarkable observations of exoplanet atmospheres.
This is all so fascinating, but I have to admit, I'm still struggling to grasp the sheer scale of this discovery. 7 Earth-sized planets around a single star. It just seems so unbelievable.
Yeah, it really is a remarkable finding, and it really underscores just how vast and diverse our universe really is.
It makes you wonder, what else is out there?
It certainly does. And that's exactly the kind of curiosity that drives scientific exploration.
You know, as we're talking about all this, I keep thinking back to that YouTube video, the one that sparked this whole deep dive. The creator's enthusiasm, it's almost as fascinating as the discovery itself.
Yeah, he's clearly passionate about this stuff.
Yeah.
And that passion, well, it's contagious. It's a good reminder that science isn't just about cold, hard facts. It's also about wonder and excitement and the thrill of discovery.
I totally agree. His enthusiasm makes me want to learn even more about the Trappist-1 system and what scientists have been discovering since 2017.
That's a great instinct. This deep dive, it's just the beginning. There's a whole universe of information out there just waiting to be explored.
And speaking of exploration, there's one thing we haven't touched on yet. The possibility of actually sending a spacecraft to the Trappist-1 system. Is that even remotely feasible?
That's a great question. And it leads us to the next part of our deep dive, the challenges and possibilities of interstellar travel.
Interstellar travel, huh? That sounds like something straight out of Star Trek. Is it even possible, like with our current technology?
Well, it's definitely a huge challenge. The Trappist-1 system is about 39 light years away, which means it would take light, the fastest thing in the universe, 39 years to travel that distance.
Okay, so even if we could build a spaceship that travels at the speed of light, which we can, it would still take almost 4 decades to get there.
Exactly. And with our current technology, it would take much, much longer. We're talking thousands, if not tens of thousands of years.
So realistically, sending a human crew to Trappist-1 is out of the question, at least for the foreseeable future.
Yeah, a crewed mission is definitely beyond our current capabilities. But that doesn't mean we can't explore this system. In other ways,
like what? We can't exactly send a rover there.
not yet. But there's some exciting concepts that are being developed. For example, there's this idea of sending tiny chip-sized spacecraft propelled by lasers at a significant fraction of the speed of light.
Wait, tiny spaceships powered by lasers? That sounds straight out of Star Wars.
I know, right? It might sound like science fiction, but it's a serious concept.
Yeah.
Being explored by organizations like Breakthrough Starshot. The idea is to use powerful lasers here on Earth to accelerate these tiny spacecraft to incredible speeds,
And how fast could these starships travel?
potentially up to 20% of the speed of light.
Wow, that's still incredibly fast. How long would it take them to reach Trappist-1 at that speed?
It would cut the travel time down to about 200 years.
Okay, that's still a long time, but it's definitely more within the realm of possibility. So what kind of information could these starships gather?
Well, they could be equipped with cameras, sensors, and communication equipment to capture images, collect data on the planet's atmospheres and surfaces, and even send that data back to Earth.
So even though we might not be able to get there ourselves anytime soon, we could still get a much closer look at these planets.
Exactly. It's a way to extend our reach beyond our solar system and explore these distant worlds in unprecedented detail.
It's amazing to think about the possibilities. But let's bring it back to the here and now. What are scientists currently doing to learn more about the Trappist-1 system?
Well, the James Webb Space Telescope, it continues to be a crucial tool for studying these planets. Scientists are using it to gather more detailed data on their atmospheres, looking for those telltale biosignatures that we talked about earlier.
Right, so we're still in that exciting phase of discovery, where we're trying to piece together the puzzle of these distant worlds.
Exactly. And each new piece of data brings us closer to understanding the nature of these planets and their potential for harboring life.
You know, thinking about all this, it makes me realize how much our understanding of the universe has changed just in the past few decades. When I was a kid, the idea of other Earth-like planets was pure science fiction.
Yeah, it's true. The field of exoplanet research has really exploded in recent years. We've gone from knowing of only a handful of planets outside our solar system to discovering thousands of them.
And with each new discoverer, the possibility of finding another world that could support life seems more and more likely.
It really is an incredible time to be following these advancements. Who knows what groundbreaking discoveries await us in the years to come?
I know. That's the beauty of science, isn't it? There's always something new to learn, something new to explore, something new to wonder about.
And that sense of wonder is what drives us, to push the boundaries of knowledge and explore the universe around us.
Well said. Well, as we wrap up this deep dive into the TRAPPIST-1 system, I want to thank you for sharing your expertise and insights with us. This has been a fascinating and thought-provoking journey.
It's been my pleasure. I hope you've enjoyed exploring this remarkable system with us.
And to our listeners, we hope this deep dive has ignited your curiosity about the TRAPPIST-1 system and the vast possibilities that lie beyond our own planet. Keep exploring, keep learning, and keep looking up at the stars with wonder. Who knows what amazing discoveries await us out there in the vast expanse of the universe?